Look at practice question set number 28 that was due today. All of these questions are based on Millikan's oil drop experiment. You can see that this information is about a version of Millikan's oil drop experiment that some students performed using plastic beads as opposed to oil droplets. That's fine. Okay, it works the same way. The beads are charged the same as the oil droplets would be charged. They're nice uniform shapes, which makes life a little bit easier. Okay, but in the end, our analysis ends up being exactly the same. Now, if you scroll down here, it talks about three different beads here. Bead X remains suspended. Bead Y moves upward, or sorry, toward the top plate at a uniform speed, and bead Z travels upward toward the top plate, accelerates upward toward the top plate at 14.7 meters per second squared. And then we have some free body diagrams down below, 5 free body diagrams, which seems a little bit odd right now because we only have 3 particles. But let's see what the question says. Question says, match the number on a free body diagram to each of the beads. All right, so they're giving me 5 options for free body diagrams, and I have to figure out what each bead would be best represented by. Bead X. Bead X remains suspended. What do we know about the forces if it remains suspended? Chase? Good. So that means it's going to be 3. Bead X is going to be represented by free body diagram 3. Y moves toward the top plate at a uniform speed or a constant speed of 0.025 meters per second. The actual value of the speed is really irrelevant, right? Moving at a constant speed, that's what's important. What do we know about the forces when something moves at a constant speed, either up or down? Joshua?
They're equal to each other.
Good. They're going to be balanced again. So this one would be 3 as well. Remember we said when we analyze Millikan's oil drop experiment saying Fe equals Fm? That's applicable whenever we have a charged particle that's suspended or traveling at a constant speed. What about the third one? Accelerating toward the top plate at 14.7 meters per second squared. Can we? It would be 5. I'm going to put a little asterisk beside that though, because that's not quite correct, although it's the best possible thing that you could put here. If that was truly correct, and they've made a mistake on this when they made the question, if this was truly correct, that force, that electric force pointing upwards would go up to about there. Does that make sense? That's not drawn to scale at all, because if you look at this as basically force of gravity 10 meters per second squared or 9.81 meters per second squared, then this would be, well, this is 3 blocks, so this would be about 15 upwards. But if it's accelerating up at 15, then we have to have 15 more than the downwards. So it would end up going, what, 2 more blocks high? By rights, it should go 2 blocks higher than it does. So, does that make sense? I mean, the best thing that we could put is number 5. You can be sure that on a diploma exam, unless they said something like, this diagram is not drawn to scale, then you can be sure that they would have that drawn 5 blocks high instead of 2 blocks high or 3 blocks high. All right, next question. So what was our answer there? What do we say? 335. The electric field in the region between the oppositely charged parallel plates. Well, we know the electric field is going to point downwards toward the bottom plate because it goes from positive to negative. We want to find the value of the electric field. We're going to do E is equal to delta V over delta D, just like we did on one of our quiz questions here. Where's our information for that? Delta V, the potential difference between the plates is 1200 volts. The distance between the plates is 0.04 meters, which gives me 3.0 times 10 to the 12 times 10 to the 2, 4. Is that times 10 to the 4? 3.0 times 10 to the 4 volts per meter, and we already said that it's downward. Yep. Oh, and number 2, this is a great question. I love this question. The nature of the charge on bead X is blank. In becoming charged, the bead has lost or gained electrons, and how many electrons? Let's worry about the charge on it first. Let's worry about whether it's Actually, let's worry about whether it's become positive or negative first, actually. If we take a look at this and we draw a free body diagram, or just draw a diagram, we know the electric field is downwards. We know that if it's suspended, the gravitational force must be downwards and the electric force must be upwards. What do we know about the type of particle if the electric force is opposite to the field? I'm positive the field is with the force, right? So if the field is against the force, Kenway, it's going to be negative, right? It's going to be a negative particle. That means it would be either C or D. It's a negative particle, which means it's gained electrons. But how many electrons has it gained? 38 or 38.2? Well, let's do our analysis here. We're going to say Fe equals Fg. We're going to say Q times E is equal to mg. Q is equal to mg over electric field. The mass of the oil drop, or I should say the mass of the little plastic sphere, is 1.87 times 10 to the negative 14 times 9.81 times the electric field strength that we just solved for a few minutes ago, 3.0 times 10 to the 4. Let's figure out what that works out to be here. What do we got? 1.87 times 10 to the negative 14 times 9.81 divided by 3 times 10 to the 4. 6.11 times 10 to the minus 18. We want to find the number of electrons here. This is the number of coulombs, right? We want to find the number of electrons. We're going to take that number and we're going to divide that by the elementary charge, which is 1.6 times 10 to the minus 19. Gives us 38.2. So our answer would be D, gain 38.2 electrons. How many people said D? How many people said D? Nobody? A couple people said D? How many people said C? C is the correct answer. Okay, why C the correct answer, Hamish? Yeah, you can't have 0.2 electrons. It's like saying how many people in the class? 26.2. Sometimes there might be 0.8 of a person kind of missing. Their body's here, but their mind isn't. Okay, but really, still, if we can't have a fraction of a person, we can't have a fraction of an electron. Okay, so if you get an answer of 38.2, it just means experimental data has given us a number that's not quite right. It has to be a whole number, though. So the answer would not be 38.2. We'd always round that. All right? You guys good with that?